We'll have about 5 minutes for questions at the end of each talk, so please wait for that Q&A slot. And just while you're still getting your devices out, our number again is 371-6942. And with that, I think I will invite our first speaker up, which is Michael Cheetham. Michael's here with us today from Barts Health NHS Trust, and we're going to be hearing about removing friction in a data flow by automated geocoding of assault locations captured as free text in emergency departments. Michael.
Oh, warning signs, lovely. You said it was a 2-hour session, so I was taking that as license to go long. So I've given this a really snappy title. My job description is almost as good, National Violence Reduction Data Manager, which I always have to focus on. And though I'm hosted by Barts, I'm paid for by NHS England, and this is working towards a national piece of work in this area. So the data that I'm talking about today is, I've got another title, is about data enabling a public health approach to violence reduction. So the Crime Survey of England and Wales identifies about 1 million violent crimes every year, so that's somewhere around 1 million people who have been affected, got the trauma, got the injury, and there is a public cost of somewhere around £34 billion a year from violent crime. So the public health approach says this violence is preventable, and we can do something to reduce it. The first step in this, the first thing to know, is who is being affected by violence, and the obvious thing to do is ask the police who has reported a violent crime to you. But people who have been assaulted won't necessarily report that fact to the police for a variety of reasons. But if you've been injured badly enough, you will turn up at hospital for treatment. And here we've got an example from South Wales in the late 90s, where someone has combed through those police records, those hospital clinical notes, and calculated what overlaps. And although this is Swansea in 1999, this finding has been reproduced across the UK and internationally since then. A lot of the work by this has been done by Jonathan Shepherd and his colleagues based in Cardiff. So this Cardiff group established a system for collecting data when someone turns up having been assaulted. They collect the how, the where, and the when of that assault. They'd then feed this data back on a regular basis to a multi-agency group, which would put in very practical measures to reduce violence. In this particular case, it was things like CCTV, restrictions on alcohol licensing, proactive police patrols at certain times and in certain places. There are other things you can do, but this is the examples that they used in the place where it has been successfully implemented. They had a great deal of success, and the slightly small chart on your right-hand side of this slide shows violence in comparator cities in the red line and Cardiff in the blue line, and you can see at the point at which they started to implement this thing they called the Cardiff model, they managed to reduce violence substantially compared to comparator cities. It's not just the success of the Cardiff model which is driving uptake of this in the NHS. Since last year, we've had a statutory duty to share anonymous data on violence with partner agencies. So one of the things that has been difficult to transfer to settings outside of Cardiff has been the capture and dissemination of assault data. Assault data has been captured as a free text string, as the where were you assaulted. It's by the pharmacy at the end of Commercial Street. But it's been mandated in the NHS since 2014. But the implementation has been really patchy for a number of reasons, partly to do with clinical systems, partly to do with the complexity of capturing it in, I occasionally work in the Royal London Hospital Emergency Department. That is a crowded, busy location during a weekday. On a Saturday night, you've got triage nurses with 2 minutes a patient. They also have to collect all the clinically relevant stuff, all the information they need to collect that person. And that person may be confused, may not have full mental capacity, may not know the local area, may be reflecting on the choices of the last couple of hours of their life that led them there. So if you're lucky, you get that very brief description of the assault location, but it's a very messy piece of text. In Cardiff, they had dedicated analysts who would go and read through all these and translate them into mappable points, but it's proved one of the sticking points elsewhere. So I'm going to take you through a methodology that translates these short strings of text into points on a map, but first to give you an idea of the kind of text that pops up. Sometimes, I'm afraid I don't have a laser pointer here, but sometimes you get really useful specific locations, like outside the old moat house. If anyone was wondering, this is made up examples around my childhood home. Sometimes you get text that indicates a broader area, maybe with a partial postcode. Sometimes you'll get something that suggests it happened at the patient's home location, so it might be at the patient's home address, or perhaps by their neighbour, which would imply an assault at home. Sometimes you get something completely irrelevant. Sometimes if the training hasn't kicked in, assault location is taken as location on the body, and you get on the arm. Sometimes you get personal identifiable data in these free text fields. That's an inevitable result of having this collected as free text. So I've got about 7,000 examples of these from the last couple of years at Barts Health. They're all about, average length is about 50 characters, and I'm going to talk you through the processing pipeline I've got for these that converts them into a location. So first of all, this is the free lunch. Postcodes are really easy to pull out with a little bit of regular expression. There are some oddities. You have to be careful that you don't map M25 to somewhere in Manchester if you live in London. But in general, you can pull out the postcode and validate it against all the UK postcodes very quickly, very easily, very accurately. If you have place names of a street, of a venue, of a wider area, there's a slightly more complex routine to match the place name in the assault location description to place names from a long list of place names. Walking left to right, basically we put it through a common cleaning process before matching. At the moment, I'm taking place names from the OS Open Name product. That's just what I've developed on. I'm working to include the postcode address file, which will allow me to properly identify venues as well, because OS Open Place Name only gives you addresses down to street or some of the larger locations like hospitals and transport hubs are in there. One important part of the process is to filter the place name list down a bit by location. Postcode address file is 32 million lines. Aside from the computational cost of trying to match against that 32 million lines, you've got a substantial risk of false matches that are not particularly close. So first of all, I filter by postcode if that's present, and then I filter by proximity to the site where they've turned up, expanding that search area if I get no matches close to the hospital. Where are we? We've done the postcode. So the cleaning routine, once that has been filtered, we remove stop words, we remove common abbreviations. The phonetic encoding is interesting. This extracts the sounds from words, and it means that some misspellings can be captured, and matched, and then I identify dictionary words and words that only occur in the place name list. So this is places that have a particularly distinct name. And then I can match unigrams, bigrams, and trigrams. And I've got a set of matching rules that selects the best match. For example, I would prefer a trigram match over a unigram match. I would prefer a original token match against the phonetic encoding. This is a great example. Assault happened in the street. This place isn't that violent. And it's an example of something that I haven't bottomed out but would need to be dealt with in a operational system. Assaults at home, I use a model called fast text to establish which assaults happened at home. I have labeled examples of the text strings. Fast text is a word embedding model which can be used in a text classification mode. And I've just seen the 2-minute warning, so I won't go into too much detail, but that's the performance that we get out of it, which is not bad, but not brilliant. The final step is to concatenate all these different methods into one long pipeline. This shows how the descriptions from my test data set are matched against what they should be. So in this data set, I had about 100 things that should have been matched, which fell through into that bucket of no match. And I had about 30 things which were matched against the wrong place. Now, that's not perfect, but for the purpose of the information sharing to tackle violence project, it's good enough because you're generally looking to identify multiple assaults in an area. You're looking to identify patterns you've got enough, if you have several assaults, you will be able to identify that spatial coverage which gives you the information you need. There's a few improvements to make, but I'm going to leave you with this set of conclusions. I'm funded by NHS England. I'm trying to work to get this into the emergency care data set. There are information governance hurdles, as you might imagine, and there are technical challenges to overcome. I'm currently piloting this in London, and it is working reasonably well. And I will be continuing to work on this for the next year or so. Thank you.
Thank you very much indeed, Michael. We'll try. We've got a couple of questions on Slido, so maybe we'll try and get those up on screen. In the meantime, if we do figure out how to do that, this is a really difficult problem to kind of push that free text through any kind of structure and get structured data out at the end. It strikes me you're going to need some kind of human augmented element here. If you looked at that, kind of how do you train the human to put in useful free text?
So I think that there's two bits of it. There's putting in useful text at the start, and there's been some training in London to improve that. The other bit, I think, is something that has to be worked through as we go through some of the IG and some of the process around building it into the emergency care data set. You can imagine that there might be regular evaluation of the accuracy. You might throw out ambiguous matches because you can get a quality score on some of them. So there are definitely things you can do, but it's and there are going to be some choices that have to be made as it's implemented.
Well, I guess you've got this kind of pipeline on which you can do that kind of iteration now, I suppose. Are we able to display stuff from Slido? How does this work? Okay.
Technical team saying no.
All right, well, we'll try. I'm going to pass on then a couple of questions. One was raised by Lily, who's kind of eagle-eyed on your crime rate stats early in your presentation, noting there was some kind of spike in 2002. around the sorts of...
You would have to ask Cardiff about that. There's a, if you look for Cardiff model evaluation, you'll dig out the original papers, and I don't know what I can't remember off the top of my head what that spike is.
No problem. I guess there is an interplay here, isn't there, between kind of health recording and police recording.
And one of the things that is relevant is that police recording in 2020 in London, where this data comes from, is very different to police recording in 1999 in Swansea, so it's not the same picture, but we don't know quite what it looks like.
And a last question, drawing again from slide, anonymous question, but you spoke about using phonetic encoding, but have you experimented with other simpler kind of spell check type techniques, Levenstein distance, etc.?
So the advantage of, so I have, the phonetic encoding just seems to work quite well, and it picks up similar things to some of those string distance calculations in a way that seems to work in the overall pipeline. So I suspect someone could write a string distance fuzzy matching routine that you could drop in as a replacement, and you wouldn't see much change in performance.
All right. Thank you very much. We'll connect you with some of these other questions to pick up afterwards.
Thank you.
Thanks, Michael. Great.